I realized that I didn't talk enough about the idea of at least one. So question number 6 on the basic probability practice said, what is the probability that there is at least one customer to win a 50% discount among the first 5 customers that enter the store? So we know that the probability of a 50% discount is 1 out of 10 or 10% or 0.1. So it would be reasonable to assume that the probability that the first 1 out of the first 5 gets a new 50% discount would be thinking like, okay, here's our first 5 customers. This one gets a discount, and we'll say these all do not get discounts. Okay, so discount, there's a D. So we could think of this as 0.1, and then the probability of not getting the 50% discount would be 0.9, and there'd be 4 of those. But you probably realize just from the way I drew this that that discount could have been the second person that came in, or it could have been the third, or the fourth, or the fifth. So there's actually 5 different ways that I could have gotten 1 out of 5. So I'd have to multiply this by 5 to get the total probability of just getting 1 out of 5 customers that gets the 50% discount. Now let's imagine 2 out of 5. Okay, so we've got 2 people getting the 50% discount and the other 3 not. But once again, how could that be ordered? Well, maybe the first 2 people got the discount and the last 3 didn't. But maybe it was the first and the third, or the first and the fourth, or the first and the fifth, or the second and the third, and the second and the fourth, the second and the fifth. You realize there are lots of different ways to arrange 2 out of 5. So we have to think of how many ways could this occur? How many possible orders? Okay, so how many possible orders? Now, pardon me, I'm writing with my fingers, so this makes it a little bit difficult to write neatly. Then think about 3 out of 5. Once again, how many different ways are there to arrange 3 out of the 5? Could it be the first, the third, and the fifth? Could it be the third, fourth, and the fifth? Could it be the first, the third, and the fourth? All different ways to get 3 out of 5. Multiple ways to get 4 out of 5. Only one to get 5 out of 5. That would be everybody gets a discount. But you see that we're counting up lots and lots and lots of possibilities. It's a lot easier when you say at least one to look at the complement. The only thing that's not included when you say at least one gets a 50% discount is the fact that it would be nobody getting a 50% discount. So what's the probability that no one gets a 50% discount? I'll just put D for discount. Well, that means X, 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 X. Nobody gets it. That's going to be 0.9 to the 5th power. So what's the probability that at least one? That would be everyone else. That would be all the other possibilities. So the probability of at least one is going to be 1 minus the probability of no one getting the discount. So since the no one is really easy to calculate, it makes sense to just calculate at least one by doing 1 minus the probability of none.